Welcome to qnawire.
Hi, so over here we're going to have a system in which we're going to add hot water to a mixture of cold water and a calorimeter, which are going to be at equilibrium. So what is going to occur is that minus the heat provided by the hot water is going to be equal to the heat gained by the water, the cold one, plus the heat gained by the calorimeter. In this case, the heat of the hot water is going to be minus mass of hot water, heat capacity of water, times delta T for the hot water, and it should be equal to mass of cold water times heat capacity of water times delta T for water, which is going to be the same as delta T for the calorimeter, plus, in this case, the constant for the calorimeter, that is going to be big C, times delta T of calorimeter. In this case, what we can do is factorize directly the delta T from both of these quantities, and we're going to get this value of delta T. And this is going to be calorimeter plus water system. Let's call it like that. So remember that the delta T is going to be final temperature minus initial temperature. So the final temperature for all of the systems is going to be the same, since we're going to reach equilibrium by the end. So replacing this value for delta T, what we're going to get is minus mass of hot water times heat capacity of water times final temperature plus mass of hot water, heat capacity of water times initial temperature of the hot water is going to be equal to this constant over here, mass cold, heat capacity of water plus calorimeter constant multiplied by the final temperature minus that same quantity, mass of cold water, heat capacity of water plus the calorimeter constant times the initial temperature for both of these systems. So this initial temperature is going to be 23 degrees Celsius. The final temperature is unknown, and the initial temperature for the hot water is going to be 93 degrees Celsius. So over here, we just need to solve for final temperature. Let's collect all of the terms that contain final temperature towards the right to make it positive, and all the other terms with initial temperature towards the left. So the left-hand side is going to read mass hot water, heat capacity of water, initial temperature of hot water, plus these big parentheses, mass cold water, heat capacity of water, plus calorimeter constant, times the initial temperature for both of the systems. And this is going to be equal to the final temperature factorizing the contribution of mass cut of this value plus mass of hot water times heat capacity of water. Passing this dividing to the other side, we're going to get that the final temperature is going to be equal to mass of cut Cw plus C plus mass of hot water, heat capacity of water. So we just need to replace all of the pertinent values. Here, for simplification of the problem, what I'm going to do is do the calculation for this quantity in parentheses, just to make things a little bit clearer for us. And the value for that, for MC Cw plus the calorimeter constant, is going to be, we have 267.1 grams of cold water times 4.184 plus 135.5. This value is going to correspond to 253, sorry about that, 1,253.04 64, and it's going to have units of joules per degree Celsius. Okay, so all of these parentheses is equal to this value, just for simplification of our problem. With this information, now the equation reads, for mass of hot water, we have 117 grams times heat capacity of water, 4.184 joule per gram degree Celsius, times the initial temperature of hot water, which is 93 degrees Celsius, plus the very big factor that I just calculated, 1253.0464 joule per degree Celsius, times the initial temperature for cold and hot water, which is 23 degrees Celsius, divided by the factor that we calculated, plus mass of hot water times 4.184 joule per gram degree Celsius. So I want you to notice that the numerator is going to be in units of joules, and the denominator is going to be in units of joule per degree Celsius. So our final answer is going to be given in degrees Celsius, and is going to be equal to 42.66 degrees Celsius. And with that, it would be all. Thank you very much, and have a good one.